Modern physics is incredibly successful, yet it rests on a fractured foundation. Today, our understanding of the universe is divided into three towering, but completely separate theoretical frameworks. First, quantum theory governs the microscopic world, speaking the mathematical language of Hilbert spaces and complex probabilities. Second, gauge field theory explains the fundamental forces, built entirely upon the abstract geometry of fiber bundles. Finally, general relativity describes gravity and the cosmos, using the continuous curves of Lorentzian manifolds. These pillars work flawlessly in their own domains, but they are mathematically disjoint. They refuse to unify into a single underlying structure. The conflict arises from the fundamental difference in mathematical language. The smooth curves of Lorentzian manifolds cannot easily host the discrete jumps of Hilbert spaces. When we attempt to force these pillars together, the mathematics collapses into a quagmire of infinities. Reductionism has reached its limit. To resolve the fragmentation of modern physics, we must start with a radically simple foundation, a single, universal axiom. This foundation is the global balance identity, expressed by the equation x plus x bar equals 0. Here, x represents an abstract imbalance field, a fundamental distortion or excitation in the fabric of reality, and x bar is its exact conjugate partner. For every imbalance that exists, there must be an equal and opposite counterpart. This is not merely a mathematical trick. It is a strict ontological constraint, meaning the universe, as a whole, must sum to perfect nothingness. Existence itself is simply the local separation of these balanced pairs. Before we can even talk about space-time, we must ask, where does this fundamental imbalance exist? The answer lies not in a pre-existing universe, but within an abstract foundational layer we call the imbalance substrate. Imagine a primordial network of discrete points, denoted as S. At this foundational level, there is no geometry, no distance, and no time. There is only raw connectivity and potential. Attached to every single node in this network is a local complex vector space, which we label V_P. This is the mathematical arena where the imbalance fields actually reside and interact with one another. The reality we experience, the smooth, continuous fabric of spacetime, is not fundamental at all. Instead, it dynamically emerges from the complex web of relationships and alignments between these local vector spaces. In this framework, the universe enforces a strict rule of balance. It fundamentally prohibits the existence of any one-sided degrees of freedom. To maintain this equilibrium, the theory introduces a universal conjugation map. This isn't just a simple mathematical flip. It is a profound geometric pairing rule. This single map unifies concepts that standard physics treats separately. It simultaneously encompasses charge reversal, spatial parity inversion, time reversal, and fundamental duality. Whenever a field state X emerges, the conjugation map guarantees its equal and opposite partner exists, ensuring the global balance identity remains perfectly zero. In standard physics, the linear nature of quantum mechanics, where states can be added together in superposition, is often treated as a foundational assumption. But why should reality behave this way? The unified balance framework provides a profound answer. Quantum linearity is not an assumption, but a direct mathematical consequence of the balance identity itself. Recall our core principle. Every imbalance field must pair with its conjugate to perfectly balance to zero. Because this fundamental constraint is mathematically linear, it dictates how states can combine. If we have two valid balance states, let's call them x1 and x2. Any linear combination of these states, scaled by complex numbers, must also perfectly satisfy the global balance requirement. Therefore, the complex Hilbert spaces that define quantum mechanics are not arbitrary rules. They are the inevitable geometric spaces where global balance is maintained. In quantum mechanics, we constantly rely on complex numbers and phases. But why are they absolutely necessary? Within the unified balance framework, quantum phases are not just arbitrary mathematical tools. Instead, they act as precise geometric descriptors of the underlying imbalance pairing structure. Imagine a phase circle in the complex plane. The angle of a vector represents its specific alignment. To maintain perfect global balance, the conjugation map must exactly reverse these phases. Therefore, complex numbers are inevitable. A phase angle theta must always be perfectly countered by its conjugate, minus theta. If the universe is built on a foundation of perfect balance, how does it change over time? We must look at the derivative of the balance identity. Time evolution cannot arbitrarily create or destroy this equilibrium. As the state moves forward, the fundamental condition, x plus x bar equals 0, must be strictly preserved at every moment. Taking the time derivative of this identity, we find that the rate of change of the imbalance field, plus the rate of change of its conjugate, must still sum to 0. This geometric constraint naturally gives rise to the Schrödinger equation. The generator of this time evolution, the Hamiltonian, emerges directly from the transport rules. Therefore, the Hamiltonian must be Hermitian, meaning h equals h bar. This isn't an arbitrary quantum postulate, but the only way to keep the universe in balance as time passes. In standard quantum mechanics, entanglement often seems like a spooky, inexplicable connection at a distance. But in the unified balance framework, it has a precise geometric meaning. Entanglement is simply the canonical decomposition of imbalance across multiple subsystems. It is exactly how the underlying substrate shares imbalance to maintain a globally balanced state. When these quantum subsystems interact, their local imbalance fields couple together tightly. They become perfectly aligned to ensure that the total conjugation symmetry of the universe remains unbroken. What we traditionally call a quantum measurement is actually a physical imbalance projection. The system collapses into one channel, and the famous Born rule simply reflects the fraction of the total imbalance magnitude. In traditional physics, we often think of entropy simply as a measure of disorder or chaos. But in the unified balance framework, entropy takes on a profound new meaning. It is fundamentally about multiplicity, a single macroscopic state of imbalance. What we observe as a stable physical system can be built from countless microscopic configurations. Entropy simply counts the number of these microscopic imbalance patterns, denoted as omega, that satisfy the same global balance. It is not merely decay, but a vast combinatorial space of ways the substrate can remain perfectly balanced. In classical physics, we typically understand temperature as simply the average kinetic energy of moving particles. However, the unified balance framework introduces a radical shift. Here, heat and temperature are fundamentally geometric properties. Within this model, temperature is strictly defined as conjugation curvature, a structural twist in the underlying imbalance field. Think of the microscopic configurations. Conjugation curvature measures the exact physical resistance of these patterns to being reversed. The greater a system's resistance to this fundamental pairing reversal, the steeper the curvature, experienced macroscopically as temperature. If temperature is the curvature of imbalance, what is gravity? In this framework, space-time itself is not a fundamental stage. Instead, the geometry of the universe emerges dynamically from the flow of entropy. Imagine an abstract boundary, a Rindler horizon. As energy flux passes through this horizon, it alters the local thermodynamic balance. To maintain the global balance identity, the substrate must generate new spatial area to accommodate this entropy. This macroscopic manifestation of thermodynamic balancing is exactly what we experience as gravity. Einstein's equations emerge naturally, acting as an equation of state for this underlying entropy flow. Up to this point, we have seen how space, time, and forces emerge from the fundamental balance identity. But how do these distinct domains interact? The answer lies in the mathematical centerpiece of the framework, the unified connection. Denoted as A mu, this single mathematical object is the universal transport mechanism for the imbalance field. It seamlessly decomposes into three distinct layers. First, gamma mu, representing the space-time geometry of general relativity. Second, the internal gauge fields, A mu, which are responsible for the fundamental forces. And finally, HMU, the quantum Hilbert components. Together, they transport reality across all sectors simultaneously. We have now arrived at the climax of the unified balance framework. After combining geometry, forces, and quantum phases into a single mathematical object, we reach the master equation. The fundamental unification equation is breathtakingly simple. F mu nu equals 0. This single statement of zero curvature is the core physical principle of the entire framework. From this one universal constraint, the fragmented laws of modern physics emerge as mere projections. It is a single source casting distinct shadows across different sectors of reality. Project it into macroscopic spacetime, and you recover Einstein's equations for general relativity. The curvature of gravity is just one facet of this global balance. Project it into the internal gauge sectors, and Yang-Mills theory appears, governing the fundamental forces. In the quantum realm, it yields the Schrödinger equation, one single curvature condition, perfectly balanced, explaining all forces and matter. We no longer look for forces. We only look for balance. Under the unified balance framework, the complexity of the universe exists merely to maintain the simplest state of zero. Viewed through the unified balance framework, cosmic inflation undergoes a radical reinterpretation. Standard models rely on an artificial inflaton field to drive rapid expansion. But here, inflation isn't an added ingredient. It is the inevitable result of the underlying substrate minimizing its conjugation curvature. Imagine a primordial state filled with chaotic imbalance gradients. As the system universally seeks to restore balance, these sharp gradients are rapidly smoothed out. This smoothing process manifests macroscopically as an exponential expansion of space, described by the scale factor proportional to e to the power of ht. In standard cosmology, dark energy remains one of the most profound mysteries, driving the accelerated expansion of the universe. But within the unified balance framework, it emerges naturally, rather than an arbitrary cosmological constant. Dark energy is understood as global conjugation tension. At cosmic scales, it becomes geometrically impossible for all imbalanced pairs to perfectly align. This inability to achieve perfect global balance creates a residual tension across the substrate. Imagine a cosmic fabric that is fundamentally stretched, continuously resisting perfect equilibrium. This tension manifests macroscopically as dark energy, leading to a specific, testable prediction for the equation of state. W equals -1 plus a tiny deviation epsilon. A true physical theory must not only explain the universe, it must be empirically vulnerable. It must offer clear conditions under which it can be proven wrong. The unified balance framework establishes strict hard-fail conditions. If experiments detect large primordial gravitational waves from inflation, the theory is ruled out. Similarly, if the dark energy equation of state is measured to be exactly -1 with no deviation, or if cosmic string signatures are completely absent, the framework collapses. Its immense value lies precisely in this rigid confrontation with experimental reality, leaving no room for adjustable parameters. What is the true meaning of existence? Under the framework of unified balance, existence itself is not a fundamental attribute of reality. As the theory states, existence is the expression of imbalance within a globally balanced system. We are not isolated entities in the void. Every particle, every force, and even time itself is not a fundamental background, but an emergent result of this continuous flow of imbalance. From this profound perspective, the universe exists because it is divided into local parts that observe and balance each other. The observer is not looking at the universe, but rather the universe is observing itself through local imbalances. Here, subject and object unite. We are finally no longer facing a fragmented physics. Through the observer's perspective, we see a geometric whole, perfectly balanced at every frame and every point. We are the consciousness of the universe, silently gazing at our own reflection.